to be talking very briefly about how I use Globus Compute to do task orchestration across a lot of different compute resources. Looking around, most of you have one of these, maybe one of these. If you look at my desk at U Chicago, you might see a couple. Some of us use supercomputers all over the place. The cloud instances that you forgot about 3 years ago, now your boss has been paying for it for a long time. And let's never forget the Raspberry Pi that's been sitting in your closet for a couple of years. So what do all these systems have in common? Well, we're here, so they all have Globus Compute on them, of course. So what more could you really want? Like, what? Nothing, right? Well, as a great man once said, with great power comes way too many endpoints. So can any of you tell me which one of these endpoints this code will run the best on? Probably not. Even if you knew what these endpoints actually map to, that might be a tough ask. So my PhD in one slide is how do we get from this model of submitting Globus Compute functions with the function and the UUID of where you want it to run to just submitting the function. So we have the system that we started building like 4 years ago. We took a little break, as one does. We call it Delta, distributed execution of lambdas with trade-off analysis. The name is changing, but the general idea is that it's a lightweight wrapper that sits in front of Globus Compute, where we intercept your function, we make some sort of scheduling decision, and then we use Globus Compute to do all of the distribution. So you don't need to run anything like a custom endpoint or anything fancy on the actual place where the compute is happening. It's basically just a layer that sits in between you and Globus Compute and makes better decisions than you, I'm not going to say than you could, but then you would want to take the effort to make. So what's novel about this? Well, it means we get to use queued and non-queued systems together, which is really cool. So, think running workloads simultaneously across your laptop and supercomputers. A really awesome new feature that the Globus Compute team has launched recently is this multi-user endpoint, which I think we talked about yesterday. And what this allows us to do now is unique endpoint shaping. So if we have multiple different types of tasks, we can kind of do a packing problem and fit different tasks together on one endpoint. We can also vary the number of cores per worker or workers per node, nodes per block, when we launch these endpoints in order to more optimally use the resources. In this very, very simple case, this top row, we have multi-user endpoint shaping results for sleep tasks. So obviously sleep is going to run best if you have one sleep task before. And slowly the scheduler figures that out. But in the bottom with matrix multiplication, Python's default NumPy, when you just pip install NumPy, it's already uses multiple cores. And so if you pack too many matmals in simultaneously, they start to have cotenancy issues, and you don't actually get any faster by packing more and more matmals in. And so the scheduler also figures that out. So what does this kind of look like? Right now, we're focusing our efforts on sort of these large scatter-gather operations where you have some centralized compute, then you're sending out a bunch of tasks, getting results, and kind of repeating this process. And so we're just placing those different individual compute jobs where they will run best. One use case we have is this molecular design workflow, which is from this TAPS framework, which Greg will talk about in a little bit. But basically, it's the same batch-based scatter-gather operation. And what we found really cool about this is, like a lot of things like machine learning training, apparently molecular design, is a lot of these have this diminishing return. Over time, it's kind of a logarithmic curve. But as we get better and better at using our resources, you can kind of delay that logarithmic disadvantage and delay the marginal utility effect, diminishing marginal utility effect, for just a little bit longer. If we wait until queued systems become active, then we can wait even longer for the diminishing marginal utility. So what's next? We really want to get to DAG-aware distribution because we think that can be really cool. Obviously, there are things with data locality there, data movement. I have a very, very simple data control pattern right now that uses magic wormhole, which is an awesome utility. And then eventually too, we want to get this to have a standardized executor interface. So it really just becomes a drop-in wrapper for Globus Compute. And basically, rather than using a Globus Compute executor, you can use a Delta or whatever the post-Delta name executor is, and drop it into any of your workflows. Make life easy.